our SHM, right?
This meeting is being publicly streamed.
Yes. So most probably, I told you that there is one independent question from this from 8 to 10 marks, right? So that is why this topic is important. So what we are going to discuss in this topic, we will talk about that what is oscillation or what is simple harmonic motion. Basically, oscillation or simple harmonic motion is a type of vibratory motion, right? What is that? That is a type of vibratory motion, and it has three main areas to discuss: free oscillation, damped oscillation, and forced oscillation. Okay, Jivita. ओ आई सी यस हाँ मैं तो शेयर ओके ओके हो गई अब देखिए हो रही है एनी कंफ्यूजन इन दैट ओके सॉरी तो मैं ये कह रहा था कि बेसिकली ऑसिलेशन और सिंपल हार्मोनिक मोशन इट हैज three main types three main classifications. The first one is actually the free oscillation, right? Almost 70% questions are there from this, and then remaining 30% are from damped oscillation and forced oscillation. ठीक है? So in this free oscillation, what do? We can consider that the object is oscillating or object vibrates without any additional, without any external force. That can be a resistive force, that can be a driving force. So the oscillation in the absence of driving force or resistive force, that is called your free oscillation, right? So basically free oscillations means that oscillation that is due to the natural momentum of the body, right? So that oscillation is usually due to natural momentum of the body, so that is why we call it free oscillation. Because the free oscillation में क्या होता है? The oscillations are we have the kinematics of free oscillation. Yes, in this free oscillation topic we will talk about the kinematics of free oscillation, simple harmonic motion, and energies of oscillation. These are main three further classifications of your chapter. So if we talk about kinematics of oscillation, so as you know kinematics में क्या क्या होता है? We have displacement, velocity, acceleration, is it? है ना? So we can discuss about displacement and time graph, displacement and time variation, velocity and time variation, acceleration and time variation. But here there are two major destructive oscillations or variations. One of them is velocity and position, and the second one is acceleration and position, right? So be careful about these two, as they are we have some hard questions from these two oscillations, so we will look into this matter. Now when I talk about displacement, displacement is represented by x in your oscillation topic, or in your vibration, or in your waves, you believe this thing. And that displacement is actually the shortest distance between two oscillating points. Displacement is the distance between, or the shortest distance between two oscillating points. So if I say that this is the shortest distance between equilibrium position and any point before the extreme position, I will explain that in the diagram here. For example, if this is the equilibrium position, this one is the equilibrium position, and then in this equilibrium position, all the particles, they are at rest. Yani whatever the particle do we have, they all are at rest in the equilibrium position. But when we vibrate these particles, or when we oscillate these particles, then what happens? These particles will vibrate up and down, back and forth, whatever, but they will create an oscillation. In that case, for example, this particle is now shifted from this point to this point up, then it comes down, up, down, up, down, in this way. So this is basically what? This is displacement. I will talk about the displacement in detail here. So this is basically the displacement of the particle. Amplitude is what? Amplitude is x, represented by x naught, and this is basically the largest distance between equilibrium position and extreme position. During any oscillation or any vibration, if your object is able to maintain the largest displacement, that largest displacement is called your amplitude of oscillation. What do we call it? We call it amplitude of oscillation. Is it clear to everyone? In free oscillation, remember this, and this is very interesting point. In free oscillation, in free oscillation, that amplitude is constant. Okay, that amplitude is constant. Is this clear to you? Amplitude is constant. That is why we will not be able to change it. Now let's talk about one more trick here. I have suggested one trick, that displacement is always less than the amplitude. Now at x is equals to x naught, what does it mean? When the amplitude reaches to the yani when the particle reaches to the highest position, at that time its amplitude and displacement becomes equal. Okay, and that happens at when at the extreme position, is it? And one more thing, that this your amplitude is the scalar quantity in the sense it is a constant number, so it does not have any variation. But your displacement is a vector quantity. What is this displacement? This displacement is a vector quantity. Now for example, if I have drawn this diagram for you, in this diagram there is a object which is that object is there is a simple pendulum. So but for the simple pendulum I have selected two positions, right? These two positions are the positions where the object is where the object is basically oscillating. Here this is a position at the mid, yani at any, yeah, this is a sort of, you know, this is a sort of midpoint, or a sort of, yeah, that can be a sort of midpoint. So here I have taken the snapshot of that. This is basically the different pictures of that object. So beta, for this one, what do you do, or what do you think? This is the displacement of that object, that vibrating object, and this is the amplitude, because from this the object comes back to the original position. So this is the extreme position. That is why the distance between mean position and the extreme position, that is called your amplitude, right? Is this clear to everyone? Okay, now I have declared one thing here, and I believe that it will be helpful for you, and you people will be able to understand that concept. But a derivation is not included in your syllabus of any of the equation, right? Of any of the equation. But I have just given you the basic concept, yani the concept for these equations. That is why maybe on some points maybe I have put some derivation concepts, derivation phases, but that will never be asked to you. You are supposed to recall and use these equations. Okay, so recall and use. So the first equation, which is basically x is equals to x naught sine omega t, this is the equation for your displacement. And this, in this equation, x is the variable which varies with time, x naught is the amplitude of oscillation of this oscillating object, and omega is actually the angular frequency of this oscillation, or angular, yeah, you can say angular frequency of this oscillation. So beta, when this is angular frequency, at that time I can convert this omega as 2 pi by t. I can convert it into 2 pi f, and so on and so on. So according to your previous knowledge, omega is either 2 pi by t or omega is 2 pi f, and so on. So this is the equation which describes the displacement equation. Beta, displacement equation का मतलब क्या है? For example, if I say x is equals to x naught sine omega t, x is equals to x naught sine omega t, then I have given the values. X naught is 20, sine omega t, omega is 1.57 into, for time is 1.5 seconds. That means it will give you the displacement after 1.5 seconds. The displacement will be equals to 14.2 centimeters. What will be the displacement? That will be 14.2 centimeters. So actually, if you see, this this oscillator which has the time period of 4 seconds. देखो मैं इक्वेशन को यहां से भी यूज कर सकता हूं. I can use this equation right from here. How? That x is equals to x naught. X naught is how much? 20 into sine. What is omega? Omega is equal to 2 pi by t into t. Beta time period is 4. So you can simply say x is equals to 20 sine of 2 pi by 4. Okay. Into time. Time, this is an equation. So that is why your equation will be 20 sine pi by 2 into t. So what can I do here? I can find it out that what will be the amplitude after different intervals of time. For example, if I have a page adding capacity, yes, here I can add a page. Yeah, this one. So for example, if I have a wave and that wave is somehow, this is a wave, okay, and this wave has a time period relevant to its oscillation. Okay, so that wave definitely it will have a time period, na? Isn't it possible कि इसका कोई time period no? Yeah, it will have. So when it will have a time period, so first of all, I must consider here what is the time period of this wave. So let's say on this graph, I'm showing you this is 0, this is let's say 2, this is 4, this is 6, this is 8, 10, 12, 14, and so on. So this axis is your time axis. And what about this axis? This is your displacement axis, right? Amplitude axis, displacement axis usually. So Betaji, when we talk about this, it means that this displacement was, how much was that displacement? This displacement was 20 centimeter. How much was that? 20 centimeter. So now if I want to find out, if I want to find out the time, uh, time period of this wave, or sorry, the amplitude of this wave at, let's say, yeah, almost this is okay. बताइए जी, if I want to find out the time period of this wave after 2 milliseconds, then how to do that? Yes, 2 milliseconds. Yeah, 2 seconds. Time is in seconds. So you can use x is equals to x naught sine 2 pi by t, yani sine omega t into small t. So x naught is 20, sine 2 pi by time period is how much? 4 millisecond or 4 second. So this is your independent variable. So here you will say 20 sine pi by 2 into t. Now this is that equation that will give you the displacement at any instant of time, right? For any instant of time. For example, if you are asked, okay, what is the displacement? What is the displacement at x is equals to 2 seconds? Yes. From your equation, sorry, from your wave, you can find out the displacement 0. Is it not? Do you agree? How much displacement do we have after 2 seconds? It is 0. Yeah. So if I apply this equation, x is equals to 20 sine pi by 2 times 2. So what will be this number? By calculation, 2 and 2 will be gone. So x would be equal to 0. Do you agree? Is it clear to you? 20 sin pi कितना होएगा आंसर? 0 ना? Now it is very yani obvious technique. If I want to find out the time at any displacement at any instant of time, for example, according to this can be, let's say, 0.3 seconds, right? What is this time? 0.3 seconds. So if I want to find out the displacement of the wave after 0.3 seconds, so I will write this equation, sine 2 pi by t into small t. So that is 20 milliseconds sine of 2 pi by 4 into 0.3. So please use your calculator and give me the values here. Yes. Yes. So that is 6 centimeter. Hanzala, बात समझ आ रही है बेटा? Hanzala, are you there in the class? अब आप देखो. What about this? It is almost 6. तकरीबन. Isn't it? Are you getting my point? So remember this thing, that whenever you are going to calculate the displacement versus time, use this equation. Okay. Now, that can be a cos equation, cosine equation also. For example, if you don't have that, x is equals to x naught cos omega t, then how will your oscillation look like? So for that cos omega t, beta g, your equation will be something like this. This way. Are you getting my point? Isn't it ना? So sine के लिए कैसा दिखेगा आपका ग्राफ? It will be something like this. This is sine graph, because at time t is equals to 0, it is 0. But at time t is equals to uh, yani after 90 degrees, it becomes 0. So if I say that if you have this equation, yani this graph, then equation would be something like this. Okay, is it clear to everyone? So at time t is equals to 0, at time t is equals to 0, what is your displacement? Your displacement is 0, maximum. X is equals to maximum at time t is equal to 0, so cosine graph. And when x is equals to 0 at time t is equals to 0, then sine graph. Okay, is this clear to everyone? Okay, now I will be talking about the velocity. Okay, the or I mean the velocity of simple harmonic motion, or velocity of the body, it is oscillating. So its velocity is having the equation v is equals to x naught omega cos omega t. I have written this in different colors due to some reason, and the reason is, here this is the variable function cos, and this is basically a constant x naught omega. So if I say that it is v is equals to x naught omega cos omega t, so it would be very clear to you that v is equals to x. Okay, I have basically tried to give you it. X is equals to x naught, or do you know velocity is delta x by t? Maths लेती हो आप? Yes, Zoya and Hamzala. I'm saying that, yeah, this is a basically mathematical trick. Okay, that the displacement is the derivative of velocity. So it is x is equals to x naught sine omega t. ठीक है? Divided by t. Divided by t does not mean divided by t typically. It means that it is derived, it is derivated. So when it is derivated, it is x naught sine omega t is basically velocity is the derivative of displacement. So the derivative of sine is cos. So that is why v is equals to x naught omega cos omega t. So you have to recall this, please. Use and recall and use, recall and use. ठीक है. अब देखो. Now I will use this equation in different way. Yeah, did you see? The black one is the equation of velocity and the red one is the equation of displacement. Is it clear to you? The reason for this was that V was equals to V naught cos omega t, which was further written as x naught omega cos omega t, and the displacement was written as x naught sine omega t. Now here this is the maximum velocity. What is this? This is x naught omega is the maximum velocity, and beta ji, this maximum velocity means that we can calculate the velocity at any instant of the time. Definitely I will talk about this in detail, but variation in the velocity is something different. For example, your maximum velocity is when your displacement of the body is zero, and when the velocity is zero, when the object is at the extreme position. Okay, when the object is at extreme position, then velocity would be zero. Now moving on this way, here is the equation of acceleration for you. Beta, acceleration is equals to x naught minus x naught omega square sine omega t. This is the equation of acceleration. So this equation of acceleration is going to be derived from velocity, and that is why we say that acceleration is negative times of x naught omega square sine omega t. X naught omega square sine omega t. So this a is equals to a maximum acceleration, yani this acceleration is your maximum acceleration, and sine omega t. So beta, this all these equations I have set adjusted all these equations in a form of a set. That is, you can have the velocity in this way, that velocity is sorry, displacement is equals to क्या होंगी, तीनों equations याद करनी है हम लोगों ने. So when we are going to memorize all these equations, we have to be very careful about that, that v is equals to sorry, x is equals to x naught sine omega t, then v will be equals to x naught omega cos omega t, and then the acceleration will be equals to minus x naught omega square sine omega t. So this is basically the difference in all these three equations. You got this point? Is it clear? So please recall these three equations for you. They are really helpful for you, these three equations, and I hope that these equations will be very clear to you, and you people would be very clear to these equations as well. Clear? Hai? Okay. Okay. So Hanzala, I'm moving back to this point. Okay. Yeah. So these three graphs are there. You know, if I just draw these graphs for you, for example, this was the graph of your displacement, right? The same will be the graph of your acceleration, but that will be in opposite direction. Sorry, that graph will be opposite, yani that will be mirror image. Mirror image, do you understand mirror image? This way, this way, sorry, this is the mirror image. ठीक है ना? So if you have this graph, this is basically your sine graph, and the lower one is your acceleration graph. This is your acceleration graph. Okay, so we will consider these two graphs right here. This is your acceleration graph. So they are the mirror images of each other. ठीक है? But what about the cosine graph, which is not here? Cosine graph किसके बराबर होगा फिर? Yes, cosine graph will be something like this. Yani at 0 it has a maximum position, maximum displacement, isn't it? ऐसे ही होगा ना बेटा? So basically, this is why these three graphs are there, and I believe that it will be very clear to you. So this one is, one of them is the velocity, yani this black one is velocity graph. This is your velocity graph. This one is your displacement graph. Sorry, acceleration graph, and the purple one is your displacement graph. So, is there any confusion, or do you have any question in this topic? Clear? All clear? Okay. So, in the next topic, inshallah, we will be talking about the acceleration versus position. Right. So, till this, I believe that it would be very clear to everyone. Any doubt? हाँ, अब बताओ जोया, इधर तक ही पढ़ा हुआ था पहले भी? ओके, बस यहाँ से आगे हम लोग इंशाल्लाह नेक्स्ट में कंप्लीट करेंगे. दिस इज द कंप्लीट टॉपिक एंड आई वाज थिंकिंग दैट यस आई हैव कंप्लीटेड विद यू पीपल. दैट इज व्हाई. आप लोगों की नेक्स्ट क्लास कितने बजे से कितने बजे तक शुरू हुई है? बस ठीक है, ब्रेक कर लो, थोड़ा फ्रेश हो जाओ, देन आई विल हैव नेक्स्ट क्लास. ओके, सी यू देन. अल्लाह हाफिज. अल्लाह हाफिज.